Alright, so in this video, we will take a look at when can we apply our cosine rule. So let's just write back our cosine rule just for a recap. So cosine rule states that if I have a triangle, okay, if I want to find one of the lengths, I can have a square equals to b square plus c square minus 2bc cosine a. Okay, so this is our cosine rule itself. So when can we apply our cosine rule to find the unknown lengths and the unknown angles? Now you realize that in sine rule itself, we have gone through one of the cases where it says that if I have two sides and a not included angle, and I specifically mentioned the not included angle part, okay, then um, we use the sine rule. So what happens if we have an included angle? That's where we will use our sine rule itself. So if I have two sides and included angle, we will use the sine rule. Sorry, we will use the cosine rule itself. Okay, so let's take a look at one of the examples where we can use this. So in triangle ABC, AC equals to 12 cm, AB equals to 18 cm, angle BAC equals to 49 degrees. Find BC, angle ABC, angle ACB. So over here, let's draw out the triangle again. As long as it's a geometric equation and there's no diagram drawn for you, it will always help you to draw out a triangle, because then you know the positions, the relative positions of the angles and lengths, and you know whether the angle is included or not. Okay, so AC equals to 12 cm, AB equals to 18 cm, angle BAC equals to 49 degrees. So now the first thing we will note is the fact that, hey, my 49 degrees is the included angle between the two given lengths. Included angle between the two given lengths. So immediately you realize that I can use my cosine rule to solve for this particular one. Okay. So you realize that the included angle actually play a very important role in trigonometry itself. Okay. So immediately we know by cosine rule. Okay. By cosine rule, okay, we can easily have a square plus b square. So your a square is what I want to find, so it's bc square equals to your ac square plus ab square minus 2acab cosine of the included angle, so angle bac. Okay, and then just simply substitute in, so bc equals to ac square, so that will be 12 square plus 18 square minus 2, 12, 18 cosine 49 degrees. Okay, so solving for BC, I will have 12 square plus 18 square minus 2, 12, 18 cosine 49. Okay, and let's square root the answer. We have 13.586. They always give 3SF first. Or because it's square root, so I have negative 13.586, and I will reject because length cannot be negative. Okay, so I still show the negative answer, but I will reject it lah. Okay, just to make it more proper in mathematical presentation. Okay, and of course leaving an answer in 3SF, I have BC equals to 13.6 centimeter. Okay, so that's BC done. Then now what we want to find is we want to find your angle ABC and ACB. So of course in this case, later on you will see that we can actually use cosine rule to find the angle itself. But since I'm already given three lengths and one angle, I can easily use cosine rule because of the fact that, hey, I already have this 13.6, which is linked to this. So since this two is given already, okay, if I want to use my sine rule, I can just find using this itself. So you can actually use sine rule, okay, even though this is a topic of cosine rule. So this is a very good way of showing you that, hey, it's not just using cosine rule, but you have to apply everything. So by sine rule, okay, now you realize that in the previous video on sine rule, I didn't put the by sine rule simply because you only knew one rule. Okay, but now let's make it more tidy. Let's study our working. So I want to find angle ABC. So I have sine angle ABC over the corresponding length to the angle, which is AC, is equal to, let's use one what we are given, which is the red color one. So sine angle BAC over your length, which is BC itself. Okay, so bring over, I have sine angle ABC over AC, which is 12, is equal to sine angle BAC, which is sine 49 degrees, over BC, which is 13.586. Okay, multiplying by 12 throughout, I have sine angle ABC equals to sine 49 degrees over 13.586 multiplied by 12. So I have sine angle ABC is equals to, so let's do the calculation. Sine 49 divided by 13.586 times 12, I will get 0.66660. So you know for a fact that because it's sine rule, don't forget the sine of obtuse angles. So you let's so for sine of obtuse angles, I have sine 180 degrees minus theta equals to sine theta. So because of this fact, we will have the following result. We will have angle ABC is either equals to sine inverse 0.66660 or 180 degrees minus sine inverse 0.66660. Okay, so you have angle ABC equals to, so sine inverse the whole thing, we have either angle equals to 41.8 degrees or 180 minus 41.805, 138.195. And you realize that this 138.195, if I add together with 49, I'll get more than 180 degrees. So I will actually reject this angle itself. Okay, so we have angle ABC equals to 41.805. Okay, of course, live in 1 dp, so 41.8 degrees. And then to find angle ACB, I'll just take 180 degrees minus ABC, which is 41.805 minus 49, and I will get my answer as 180 minus 41.805 minus 49, 89.195 degrees, which is of course rounding off to 1 dp, 89.2 degrees. Okay, so that's it. Okay, so that's how you actually apply your cosine rule to find unknown length. So if I'm given two sides and included angle and I want to find length, I will use the following cases itself. Okay, so this is an example of how we use cosine rule to find an unknown length in a triangle. All right, stay tuned for the next examples. Okay, we still have one more case as well as one extended example itself. All right.